This video has us beginning to explore solving equations that go beyond using two steps. So it's really important for us to begin to understand the process of simplifying, because that's what's going to allow us to take any equation that we look at beyond a two-step equation and have some strategies for making it a little easier to solve. So we're going to learn the first of those strategies, called the distributive property, today, and then in the follow-up lesson we will do another method called combining like terms. But just as a quick review before we get started, we should remember that up to now that there's been two steps at most for solving any equation. The first step was to isolate, and that means to get the variable alone. And don't forget, that required us to either add or subtract terms on both sides, okay? Then, after that, we used inverse operations to solve. And in that case, we were typically using multiplying or dividing, okay? So those are the two steps that we've gotten very used to. So today, we add a new step to the process that requires us to simplify the equation first. Simplify the equation first. And that's going to allow us to get to a point where ideally we're looking at a two-step equation that then allows us to isolate the variable, followed by isolate the variable term, followed by solving for the variable. And as I mentioned, and as you can see in the title of these notes, the first way we're going to simplify is by using the distributive property. So this is going to allow us to take an equation, which I'll just scroll down to show you, like any of these down below, and with a little bit of work, not much, convert them to a two-step equation that should get us into the comfort zone of what we've been doing up until this point. The distributive property is fairly straightforward. To distribute, we multiply. So we need to understand there's a term on the outside. So we multiply this term on the outside with the terms that are on the inside of the parentheses. And you'll notice that for our practice, there will be only two terms inside the parentheses. So we take this term on the outside, directly outside, and we essentially go once with multiplying, and we go a second time with multiplying, and the parentheses are going to disappear. And that's going to get us to an expression that has a variable and a constant term in it, which looks awfully familiar to what we see, particularly in a two-step equation. Okay, so we're going to do 9 times n. That gives us 9n. And I want you to be really mindful of how we're going to approach the next jump of multiplication. We're going to do 9 times. I'm going to treat that very specifically. I know that's a plus sign, but I'm going to treat that as the sign for the 7 that we're multiplying by. So we're going to say 9 times positive 7, which is going to give me a positive number. And the math of 9 times 7 is 63. So one more time. The distributive property has us multiply the term directly outside the parentheses inside to each of the terms in the parentheses. And by doing so, we get rid of the parentheses altogether. So 9 times n, 9n. 9 times positive 7 gives me positive 63, with the result, if we read it, would be 9n plus 63. So we'll do this again. In the next example, the term directly outside the parentheses is a 3. So we're going to say 3 times 2c. Well, we know 3 times 2 is 6. So 3 times 2c would just be 6c. Again, we're going to be mindful of the sign that we're going to see in front of this 11. I know it's a subtraction sign, but if I were to just cover this up altogether, this 2c, I'd be looking at a value of negative 11. So that tells me that I'm saying now 3 times negative 11, and I know when I multiply a positive by a negative, I get something negative, and in this case it would be negative 33. So we have 3 times 2c, 6c. 3 times negative 11 gives me negative 33, but in the context of our final result, we read that as 6c minus 33. So the actual process itself, the jumping with the multiplying, is not the complicated part. The complicated part is really keeping track of the signs. And the more we do this, the more it'll make sense to us. So there's one more with the sign here, and you notice that the outside number has a negative. So this will give us hopefully a little bit clearer understanding of how we treat the signs. So we'll start with negative 8 times 3x. We know a positive times a negative is negative. In this case, 24x. We're going to say a negative, so we have a negative here, times a negative there. Don't forget, when you multiply two negatives together, you get a positive. So a negative times a negative will give me positive or plus something. In this case, positive 72. So negative 8 times 3x, negative 24x. Negative 8 times negative 9, positive 72, otherwise known as plus 72. So this is the distributive property. So the reason why we're laying the foundation here is that we need to know how to take those expressions and make use of the distributive property when we see it in an equation. So as an example, and I'll tell you what, with these three examples, we'll work with what I think to be the most challenging one first, and then I'll leave the other two for you. So you can see here that this is now an equation. I have an equal sign. This has distributing that I need to do. This requires me to do the distributive property because I have parentheses with a number directly outside. So I'm just going to follow these quick 3 steps. So the first step is going to be that I simplify by distributing. And we just saw an example like this directly above. So negative 3 times positive 2x should give me negative 6x. Negative 3 times negative 7, we know two negatives together give me something positive. That's going to give me, in this case, 21 equals negative 9. I took care of my simplifying. The next step I'm going to move on to is my isolating. You should recognize this as a 2-step equation right now. This is a 2-step equation that's going to require me to add or subtract a term on both sides. And if I take the second to identify what each of the terms are, a variable and a constant on one side of the equal sign, a constant on the other, that tells me that this constant being alone is going to require the other constant to go join it. So we'll simply do that by subtracting 21 on both sides. Negative 6x, cancel out the 21s, equals negative 30. I've taken care of my step of isolating. My final step, again, should be looking really familiar to us now that we have a 1-step equation. We'll just quickly move through the final step of solving with an inverse operation. In our inverse operation here, to undo the fact that we're multiplying by negative 6, we'll divide by negative 6 on both sides. And we get x equals, be careful of the signs, a negative divided by a negative is positive. So x equals positive 5. So that is this process. What we've essentially done is from this point on, we have a 2-step equation, right? And we have become really good with 2-step equations. So all we're doing is getting used to this, adding this new step of simplifying with the distributive property to make a 2-step equation that we can feel much more comfortable solving. So that is now adding the extra step. So what I want you to do is to take these last 2 equations and to follow the steps up above. Simplifying by distributing, isolating as we know how to do by adding or subtracting. And actually, you'll notice these will all require us to add or subtract a constant term. And then finally, the last step of solving with inverse operations. Do those 2, and we'll get more practice when we meet again.